Welcome. This is the supplementary video for Chem 1010, finishing up on topic 6 for the fall 2025 semester. I asked everybody to make sure you watch this video because we're not having class on Friday, November 21st, so this is your video to get the rest of the material that you can have for information for quiz and exam coming up. So when we finished off with class on Wednesday, we talked about looking at oxidation numbers, how to solve for those, how to find them, so that we could see how those change to determine what was being oxidized, what was being reduced in a reaction. And we looked at that and saw, okay, if we see some element change from, say, +2 to +3, from the reactant side to the product side, that meant the oxidation number was increasing. That meant that that element was being oxidized. On the other hand, if that oxidation number went down from 0 to -2, then that element was being reduced. So this gave us another way to determine what is oxidized, what is reduced. The oxidation numbers will always work, so they're great and handy for that, but they take a little bit more work, so other methods are nice because they can make it shorter when they are applicable, when they fit, when you have oxygen present, when you have hydrogen present, when you can see the charges. So looking at oxygen, hydrogen, electrons, those options work great when you have those. Otherwise, oxidation numbers will always work. So we talked about that and even got into looking at the oxidizing and reducing agents, trying to wrap up some of that idea of how we can label what is happening during an oxidation reduction reaction. The last little bit that we haven't talked about was the applications of redox, where it gets used and how we can use and how we can see these reactions showing up. So some more information to have as background, as understanding of what was going on. So the first thing I want to point out is that with redox, it was all about a transfer of electrons, meaning that electrons are moving around during a redox reaction. We do not see them in the overall chemical equation that we write, but we know they are moving around. If we break it down and study it more, we'd see them. We're just not in this class, so we're just going to say, yes, they are there moving. We don't see them, but it is happening. When everything's together, it really doesn't do much. But if we were to physically separate the oxidation and the reduction parts, allow things to still work, but not keep them right on top of one another in the same container, physically separate them, we could have a wire connecting them that would allow the electrons to move from one side to the other. That would create a flow of electrons or a current of electrons, which is the essence of electricity. A flow of electrons creates a current. That is electricity. So redox reactions generate electricity when you separate the parts. This is how we can get things to work and how we can provide electricity for everything we do in life, pretty much. So it's all based on redox reactions. So the more we understand those, the more we can understand how to produce electricity and keep life running the way we want it to run. So another benefit to redox reactions and understanding chemistry. Beyond just looking at electricity, there's other ways that redox reactions can show up in life. One of the most common, and actually one of the ways it started being studied, was through what's called combustion. Combustion is anytime you take a chemical and burn it in the presence of oxygen gas. So make fire. That's combustion. That is a redox reaction because you're reacting with oxygen, O2. You're adding O2 to one element and something else is coming off. You are oxidizing that thing. So that is another form of oxidation. Even though it's not focused on the electricity side, it is still the same chemical process, so it's the same chemical behavior. So combustion is another example of a redox reaction. Similarly, we can have other oxidation that occurs naturally forming, such as corrosion. Corrosion is where a metal starts to break down. Most common one being iron forming rust. That is where a metal has been oxidized. And instead of being a solid metal, now it's a new product of some metal oxide. Iron becomes iron oxide. Zinc becomes zinc oxide. Copper, copper oxide. All of them are oxides of metals. Those new compounds have different properties and different appearances than the pure metal did. Rust is the most extreme one, where iron oxide is much more, can be broken down more, can fall apart more easily. It's not as sturdy as the original metal was by any means, and it flakes off. It breaks apart. So probably have seen it, heard of that, and come across that before with, oh, an old rusted metal. That's the iron oxide that's broken down. Other ones, zinc oxide, copper oxide, they definitely appear different. They're not as extreme in a difference in properties as what you see with iron. But copper oxide, I would guess that probably every single one of you have seen this without even realizing it, maybe. Because the Statue of Liberty in DC was built out of copper. The salt and the cold weather and the water present around the bay where the Statue of Liberty is at oxidized the copper to form copper oxide, which is what the green color that we see actually is. The original Statue of Liberty was a copper brown color, but it got oxidized by the presence of the salt water, and that's what we now see. It still stands, it's not falling apart, because copper oxide is not the same as iron oxide. It's not as flimsy, but it has changed. It was oxidized. The material was changed to some new compound. So that's another example of having oxidation occurring. One that's even more fun and interesting is explosions. Yes, we're going to talk about explosions. I'm not going to show you one, but we're going to talk about them a little bit. Explosions are most often, not required, but often, a very rapid, very quick redox reaction. And it's not the reaction itself that's the explosion. What actually causes the explosion is the fact that the product, or one of the products, maybe multiple products, of these reactions are gases. And so you very quickly make gas. As we saw in topic 5, when we talked about gases, 1 mole of solid, palm of your hand. 1 mole of gas, 22 liters. So when you quickly make a lot of gas, it wants to expand and go out and go everywhere else. If you have it enclosed in a container, it's going to bust that container, cause an explosion. So an explosion isn't necessarily a reaction saying, oh, we're going to blow things up. It's just a reaction saying, let's make lots of gas. And if you try to contain that improperly, then it explodes. So that's just a little bit more about what's going on with these reactions, these things you may have seen and heard of before. Now we can better understand them. And the better we understand them, the better we make sense of the matter, the more we know about what's going on. Other ways that redox reactions get used quite a bit are batteries. Every battery is a redox reaction. They're using certain materials that will oxidize or reduce, and they separate them, and that's why batteries have a positive terminal and a negative terminal. They've physically separated the two reactions. They're connected to allow things to move. That's why you put a battery in, and electricity then passes from one end around the item back to the other end of the battery, from the positive to the negative. It flows that way so that you have a flow of electricity. So we have batteries that are providing electricity because of the chemicals inside of them, because of the reactions. It's also why you have different sizes of batteries and different things they can do because of what the materials are. Some materials are rechargeable to an extent. Even rechargeable batteries will run out eventually because it's not a perfect recovery when you recharge them. But they have different materials, so they have different properties. A AA battery is very different from a lead acid battery that you have in the car. Different materials because of different requirements for what that battery needs to do. But it's all based on redox reactions. Another common or fairly common term that comes up with redox reactions is electrolysis. You may have heard of electrolysis depending on what form. You may have heard it in different ideas. But electrolysis, in its most simple form, is using electricity to get something else to happen. So whether you're using electricity to charge your cell phone, using electricity to do chrome plating because you want things to look pretty, using electricity to kill off hairs because you're doing electrolysis hair removal, all of that uses electricity, which is based off of redox reactions. So it's all very much connected. The more we understand redox, the more we understand how we can use electricity to make things shiny, to power our cell phones, to get rid of hair, to do all kinds of stuff. It's all about using it. And one that's still out there, but not, no, it's actually still more common than I was going to say. It used to be a lot more common, it's kind of fallen off now, it's kind of coming back, is the concept of photovoltaics. Photovoltaics are where they take they have material that takes in light and converts that into electricity. So a lot of calculators used to have those for those solar panels to power, so you have to have batteries. Solar panels for housing and providing electricity are photovoltaics. Photovoltaics take in the light, do a chemical reaction with that energy to produce electricity. That's redox. So redox reactions are very present, very out there. The more we can understand them as scientists, the more we understand how the matter works, the better those reactions get, the better they can produce electricity cleanly and easily, the more we can meet requirements, the more we can do other things, and yes, the more we can blow stuff up. Only just don't do that. Public service announcement. Don't blow things up unless you're a professional. But that's what redox is all about, is learning more about how these reactions work so we can find uses for them and make things work. So look over that, make sure you get that information, have that for information for the quiz and exam. That'll help round out the chapter, and hopefully everybody can be ready for quiz on Monday, the 24th. That will be our next quiz, and I'll see you all again on that day.